There we go. Hello, everyone. Welcome to Simplify Network Automation with NetGroup. I'm your host. And today we have Kyle Winters. Kyle, thank you so much for joining us on the live stream. How are you? How have you been?
I've been good. Thank you so much for having me. It's good to be on. First time, long time, as they say. Um, Excited to be here. For those who don't know me, I am a senior technical advocate on the Learn with Cisco team. I take a
Mhm.
focus on security and cybersecurity related topics, ethical hacking, AI. So happy to be here. We've obviously known each other for a while, so it's fun to get to do this together.
Happy to have you. Definitely, we've been knowing each other for a while. It's true. We were talking about doing this, so I'm glad that we finally found the slot that works for everyone. So, Kyle, before we jump into the topic of today, tell us a bit about yourself. How did you kind of get to this part of your career? You've been at Cisco, then you stepped away for a bit, then you're back now, right? The automation, programmability angle, like where do you stand on that? And how did you get to, where you are today, if you can go over that in a bit?
Yeah, so I think my introduction to tech started at a young age, probably at a similar spot that a lot of people it started at least a lot of millennials like myself. Maybe people don't realize it, but at least for me, my introduction was actually MySpace back in the day. Being able to go
Oh,
in,
wow.
edit the HTML to make your profile look like what you wanted to, and as like a young kid doing that for me felt like I was like hacking something, like I was
Mm,
changing what the intended functionality of something was to make it look unique in my own. And editing HTML and JavaScript at that time was kind of like my introduction into it. um, when I eventually went to university, I took some classes in networking and cybersecurity, and really kind of dove deeper into it and really enjoyed those topics a lot. Out of uni, I went to work for um, a large aerospace company, and I focused on their networks and their security platforms there. Eventually, moved on, and during this time, by the way, I was largely programming as well too. I was writing a lot of
mm.
code in Java, slowly starting to learn Python at the time as well, building different integrations and automations and things like that. So. Um, Eventually, I went to work for this startup called Landcope that got acquired by Cisco. That was kind of my journey into Cisco at the time. I was focused as an solutions architect, working on integrations with our product. At the time, it was called Stealth Watch. Now it's Secure Network Analytics. And through kind of that working with the APIs, that's how I eventually became introduced to DevNet, and started working on bringing things like the StealthWatch APIs onto developer.cisco.com so people could use them the way that I was trying to use them. Um, Served various roles throughout my initial stint at Cisco. Started as a solutions architect, eventually went into technical marketing, um, landed a role at DevNet for a while as well
Mm.
too. Focused on the partner specialization at the time, and at a certain point, I got invited to go work at an application security startup. Tried my hat at startups for 2 years. Was at two different ones that were very focused on application security. The first one actually being very focused on secrets and being able to identify um, things like hard coded credentials, API tokens, stuff like that. So, very relevant to the talk that we're going to have today, which we'll come back to here in a little bit. But after some time, made my way back to Cisco, now with the learning and certifications team, Learn with Cisco team. And yeah, really enjoying it, getting to speak at different events, talk about cybersecurity, teach people cybersecurity, bring cybersecurity practices and the latest trends back into our organization as well.
Very cool. So a large breadth of experience, right? From networking to development to Java to Python to cybersecurity, right? So lots of skills there for you, Kyle. So very impressive.
Yeah, I mean, there's no traditional path I'd say for anybody these days.
Yeah.
It's there's people who are very academic and there's people who learn as they go. And that's part of the fun and the nature of it. So, for me, like always be learning is one of my mottos in life. So
Mhm. Mine too. All right. So then, proactive defense, right, and building honeypots. What is that about?
Yeah, so there's let's start just kind of with the problem of
Yeah.
hard-coded secrets as a whole. And like I mentioned before, I worked at an application security startup where they were a big part of what their initial use case was being able to scan repositories and infrastructure for credentials, API tokens, private certificates, all these different things that shouldn't be exposed but were exposed. There's obviously a lot of risk with putting things like hard coded credentials or any credentials into a repository, having it exposed in like a CI/CD pipeline, as an example. So there's a lot of risk with that because somebody could stumble upon that and now use those credentials to do malicious things. So we would be going into organizations and seeing just tons and tons of these hard coded secrets exposed all over the place. And hackers and malicious actors were taking advantage of that. That's an easy way to get into an organization is just by
Mm-hmm.
scanning GitHub and seeing something that's already there that can give you the keys to get in.
Mm-hmm.
Um, so the problem of hard coded credentials exists, and it's being leveraged by malicious actors on a daily basis already today. Now, in cybersecurity, you have this general concept of a honeypot. Are you familiar with this concept?
I am, but tell us a bit about it for folks that are not aware of what it is.
Yeah, so think of a honeypot as like a server or a system that is designed to look legitimate and real. Um, but under the surface, what it's actually doing is really ultimately capturing and logging the information of people who are using it. So in practice, a actual honeypot would have no legitimate use to an organization. It doesn't actually do any functionality. It's just sitting there on the network or in the infrastructure as a decoy in a sense. And if anybody's trying to touch it or interact with it that isn't probably part of the security team, then there's a high likelihood that that person is a malicious actor who's trying to exploit that system in some sort of way. So the idea with a honeypot is leaving these intentionally kind of sometimes maybe a little weaker than usual. They appear legitimate, but they're vulnerable systems out there in your network to attract the malicious actors to go after them. So that way you can be a bit more proactive in catching them. If, let's say, you can catch them on a system that you know about, that you have a trap set up for, then you can be proactive in blocking them and taking the restrictive measures against them in your environment before they actually get to something that is running production code that's business critical. So that's the idea of a honeypot. But when it comes to secrets, there's also this concept of honey tokens as well. And think of it as this very similar approach, leaving these seemingly real looking credentials in public places. So that way, when somebody is scanning these repositories for malicious activity, they come across them. Their initial reaction is going to be, let's try to use this. This looks real. But any legitimate use of those credentials, because they're actually a trap, we know that if somebody's trying to use these credentials, they've been scanning your repositories, looking for things to exploit inside of your environment, and you can then be again proactive in blocking them. So the idea with the honey token is really creating these fictitious, seemingly real types of credentials and putting them and sprinkling them in various different places in your infrastructure, in your code, to see if somebody can catch it. And that can be things like fake API keys.
Mm-hmm.
You maybe they're put inside of a config file or documentation. It could be cloud keys. It can be database credentials, webhook secrets, lots of different things. But ultimately, the idea is to place them in places where these malicious actors are already trying to go to find them. And if they stumble across them and you can catch them in the act doing that, then you're able to be proactive in taking the measures to restrict them and block them from doing actual further damage.
Gotcha. So, honey traps. Well, honey
Honey tokens in this
honey
case.
tokens, and then honey traps. Right? Honey tokens would be um, those credentials, passwords, username, whatever it is, but
Mhm.
fictitious, trying to catch who's interested in this, who's actually scanning my GitHub repos, and who's looking for these credentials.
Yeah, I mean, we don't have visibility really into who's, especially if you have public facing repositories, um, or even in some cases private ones. Like you don't have a lot of visibility into who's going out there scanning these things, looking for secrets, sifting through your source code. So this is a great way to be proactive in doing that. Um, the kind of the way that the workflow goes for this, by the way, is typically you would generate some kind of token that looks legitimate. And then you place it, like I said before, in that config file,
Hmm.
maybe in a log somewhere. It could be in documentation as an example, but you want it to look real. You want it to look legitimate. And once you see that being used, and you can set up maybe, for example, like a fake API endpoint that it can be used to exploit. A server that's running some fake APIs, similarly to a honeypot, is another way to do it. I've seen ways that people would maybe use a SaaS service that has some kind of logging on it. And if somebody logs into a SaaS service with specific credentials, they know that they got those credentials maliciously as well. That's another way to do it. But ultimately, you want to set up a mechanism to capture those in a way that looks legitimate. In today's example, we're going to do that by setting up a fake API endpoint. Um, and what's going to happen is once somebody tries to log in with that, it's not going to let them know, hey, we caught you. It's just going to try to kind of continue seeming legitimate in some ways without exposing anything. But in the case today, it's going to fire off an alert to Splunk. So that way we can capture that inside of Splunk and have some alerting and be able to do further types of orchestration and automation around it down the road as well too.
Gotcha. So that would be GitHub sending these types of alerts into Splunk where we can.
In this case, we're actually going to set up a fake. We're going to run a Flask app that has an API endpoint that's going to be listening. It's going to be able to recognize when the honey token that we've created is used
Mhm.
versus somebody just trying to brute force in. So if I'm trying to log in, maybe I found this endpoint, but I'm just going to try to brute force a million different passwords. It's not going to alert on that. But the second this high entropy string that we will create, this token, is used to attempt to log in, then we know that that person found that token on this GitHub repository that we put out there that has this token available. And that's when we want to be extra proactive and realize that they're scanning our repositories, they found these credentials, and they're looking for other credentials as well. So let's be proactive in blocking them.
Gotcha. Okay, so let's have a look at the code, the Flask application, how everything comes together.
Let's do it. I'm going to share my screen here.
There we go.
All right, you can see that okay?
Yep.
So I've got a server that I'm running here. It's called Honey. I've got another one that I'll show you here in a little bit that's called a tagger. That's where we're going to run our attack simulation. And then I've also got an instance of Splunk running here too. We'll come back to that in a little bit. But let's just go ahead and start, just show you what we've got in here. We've got a few files. I've already gone ahead and created the virtual environment and installed the Python requirements with the requirements.txt file there.
Hmm.
But as you can see, we have two different files here. One called fakeapi.py, the other is called generatetoken.py. And the one we're going to use first is the generatetoken.py one. And let's just take a look at that. So you can see it's a pretty straightforward file. There's not a whole lot going on here. We've got our generate honey token function here near the top, as you can see. And what this is doing is it's just going ahead and creating that token. It's writing it out into a dictionary, but it's putting some things in there that make it look legitimate. For example, it's got a name, obviously, but then there's an endpoint for us. So it looks a bit more real. It's got things like the owner in there, the purpose of it, what it could be for. You can put whatever you want into these things, and you can build these out and customize them however you see fit as well. The important piece here, though, is this token value. That's going to be our actual token that we're going to be keying against. And you could use a random number generator to do this, but that's not going to look as real as using Python's built-in secrets library. So we go ahead and use that to make it look a bit more like an actual token as opposed to just a series of random numbers and strings. So that's the approach that we take there. So here, when you call this function, it's going to generate ultimately a file that looks like this, with populating that secret in there. And you can see our main functionality here is doing that logic of writing this to the path here. We're going to create a file called generated Honeytoken, which I'll show you what we do with that later. But any questions on this? It's a pretty straightforward Python package.
Yeah, I was the secrets library is new to me, so that looks interesting. And you said it's built in into Python.
Let me double check. I think it is. Take a look at the requirements here. Yeah, it's built in, so it's already
Oh, it is.
existing inside of there.
Very
And
cool.
I guess now that we mention it, I probably haven't mentioned this yet. This is a good time just to mention to the audience good practice and hygiene when it comes to secrets. You know, never store any legitimate usable credentials, API tokens, certificates, things like that. Really in your source code anywhere. You don't want to hard code those. You want to be using secure key stores, things like that. So that's just good general practice. Obviously, we're doing this and using these tokens that we're putting in here today to try to catch people doing exactly what you don't want them to be doing. But just as general practice, you know, use a key store, something like that, to store your credentials when you're working with code. Hopefully you are all already are well aware of that.
If not, there's again, right? Please don't store your credentials, like Kyle was saying. Always remind everyone about that. And Karina, thanks for joining us and for watching this. We appreciate you watching it.
Yeah, and if, let's say, for example, you stumble across somebody who's got you stumble across credentials in your organization, rotate those as quickly as you can. So we've got our script here. Let's go ahead and run this, and I'm just going to say Python generate token, and
And
that's
that's
just
going
going to
to
go ahead and run like that.
create that, generate that JSON file, right?
Yes, so you can see it wrote it to standard out here. As you can see, it also saved it to this generated token file here, and we can just take a look at that. And you can see it's written there. So it's going to be referenced here in a little bit. You can see this. This looks like a token.
Legit, yeah.
Yeah. I mean, if I stumbled across this in the wild, with the exception of maybe um, these little bits here, I would think this is pretty legitimate. We can obviously change this around how we see fit. But I mean, if this was in a config file somewhere and I stumbled across this in GitHub, this would look like a pretty legitimate secret to me, which is what you want it to do. You want it to look real, to be able to trick the people who might stumble across it into attempting to use it. So in theory, what we would do now is place this in GitHub. You might have, for example, like a config file, some environment type file that you'd put it in there. I'm not going to put it in GitHub today, but we'll just kind of talk about that. Ultimately, you want it to be somewhere where it looks legitimate. So, you know, you want it to kind of be that enticing bait, but to look real. So if you just had a file out there called honeytoken.config and you put that into a GitHub repository that didn't have any other files in it, people probably wouldn't take that very seriously and attempt to use that. That'd be pretty obvious to them. But if you took something that looked like actual code, and you had a bunch of other files in there and some other configs, and all of a sudden this token is in there, or you know, it's in a log file somewhere. Maybe you have an existing process in a GitHub repository that's already public, and you just have a CI/CD process that's running and logging out there. You could put these types of tokens in there just as decoys. They might not be used by that actual legitimate repository in any sort of way, but you're dropping these little seeds, these little breadcrumbs inside of there to know that if somebody's actually scanning your actual legitimate GitHub repository and stumbles across this and tries to use it, you know right away what they're up to. So you want to kind of put these in places where it looks legitimate, looks real. GitHub's a great place to do this. Cloud infrastructure as well is a great place to do this. Just try to make it look real if you want to try to catch people doing it. Does that make sense?
Does. Yep.
Cool. So we've gone ahead and created this token. Let's go ahead and jump into Splunk really quick. Before we can run the fake API, we need to set up just really quick an HTTP event collector inside of Splunk. So Splunk, for those who aren't familiar, is a great platform for doing security investigations, incident response, being able to pull in information, manage events that are coming in across your network. It's a great SIM tool, but it does a lot more than SIM. It's got SOAR capabilities to it as well. But this is going to be where we ultimately send our alerts from our fake API server into Splunk, so we can track this as kind of our single source of truth for events and alerts that are coming in, and be able to correlate it with other sets of data later on down the road. So inside of Splunk, you've got various different data inputs that you can do. And the one that we're going to use today is the HTTP event collector. So it's going to use TCP to capture events that come in that are registered to a specific event type. It will essentially create a token that's specific for these Honeytoken events. And when we do an HTTP post to it, it's going to be able to capture that and log that into the system. So for the sake of this, we're going to go ahead and create this new one. We're going to call it Honeytoken alerts. We'll keep everything pretty default for now, but then go ahead and click next. And for our index in Splunk, we'll just use the main one. It'll default to that. We'll just keep it pretty simple for this example here. So we'll go ahead and create that. You can see we have a new token value here. Let's go ahead and copy this really quick and come back to our command line here. And you can see if I just run ls but show all, you'll see we have this environment file here. And if we open this up, this is actually where we're storing some of our tokens for Splunk right now. So it's running locally. It's not being actually put into a repository or anything like that, but we're going to go ahead and put that token that was just created for this HTTP event collector right here. That's our IP address and endpoint for Splunk in the HTTP event collector as well, right above. So we've got this configuration saved and ready to go. Now, with respect to the fake API endpoint, you can see that file right here. It's a legitimate Flask app. It's meant to mimic a real API that exists out there, but under the hood, it's got that detection layer that might not be recognized by that malicious person. So in a real environment, you might have other API endpoints in there. So if somebody scans that particular server, they'll see other endpoints that are exposed and look legitimate. In this case, we're just doing this as an example, obviously. So it's just going to have this one endpoint. But when you try to interact with this endpoint, it's going to look legitimate. They're going to think it's real. But under the hood, when that request comes in, it's going to do some alerting asynchronously to Splunk and notify Splunk, hey, this token was used, so that way you can take action against it. Now, when the attacker uses it and they try to log into it, it's not going to say in big blaring letters, hey, we caught you, ha, ha, ha. It's just going to actually say a 401 error. It's going to say those credentials are invalid and reject it. We don't want them to necessarily think that they've got into a system successfully and try to do other things. Maybe we want them to think that the password was rotated, but we can see that them trying to use it shows that they've been out there scanning our repositories in the first place, and we don't want them doing that. So if we go ahead and take a look at this this fake API file here.
Let's see what's going on.
Yeah, so we can see some different pieces of logic in here. We're importing a few different libraries, but if we scroll down to the actual good parts of it, we can see, let me just get this all on screen here. We can see this function up here, load Honeytoken. That's where we're pulling it from our token file that we generated earlier, so it can recognize the token that we have generated, that we put out there. And if anybody's trying to use any other credentials, they're likely just doing a brute force against it. Still not great, but we don't know where they're coming from at that point. We don't know if they're scanning our repositories, trying to steal our secrets to begin with. If they use that Honeytoken that we've created, it recognizes that here, and then it'll send that alert out from there. Here's where we're actually sending out our HTTP event collector alert.
Mm-hmm.
And you can see it's pretty straightforward logic here. We're not alerting on any errors by design, because if an error occurs, we don't want to expose that error to the malicious actor. But you can see the payload here that we're putting in. It's highly customizable. You can add lots of different fields. This is what's going to show up in Splunk. So some of the fields that we have in there now include just the alert type, which is always going to say that a Honeytoken was accessed, the value of the token itself, the source IP of the person who's trying to use that, as well as some details around the user agent, the event time, and a severity. You can add additional fields in here as well, but this is what we're going to leverage now for the time being. And then the actual logic here of setting up the endpoint, again, it's just a simple little Flask app that's just going to be listening for connections coming in. It's going to look for this particular API key in this particular header here. And if it's used, it's going to log to standard out for us, as well as then send that alert into Splunk right here.
Mm-hmm.
So this is it in a nutshell. Any questions on this before we go ahead and get this running?
Pretty straightforward. Then returning a 401 error just towards the end over there.
Yep.
Invalid API
Yeah,
key.
we want to always return that 401 error. We don't want them to think that they're actually now have an API that they could use. We just want them to try to use it, because if we catch them trying to use it with the credentials that we put out there, that gives us some good insights into what they've been doing. So I'm gonna go ahead and close this, and let's go ahead and run this. So I'll just say Python fake API.py, and that's running now. So this is ready for us to go, and I'm going to go ahead and just copy this really quick here, and let's just pretend that, I'm a malicious actor. I'm cruising GitHub right now, doing different types of scans, looking for credentials that I can exploit, and I stumble across this one in a repository. Now, I might come over here, and let's just go ahead and save this. Let's put this into our attacker's host here. Write this here, and just before I save this, we've got some good info from what we've just found in this config file, cruising GitHub. We see an endpoint. In my case, it's a private network, but it would be public ideally in a real scenario, production scenario. We've got a token here as well too. We know we got this token. We know we got this endpoint. We can go ahead and try this and see if we can get into this system and compromise it further. So I'm going to go ahead and save that really quick. So we've got here a couple different files. I showed you this stolen token when we just wrote that. But the attacker sim, this is what we're going to run. And it's just a very straightforward Python file here. I mean, it's just basically loading that token in from that file. And then it's just going to try to use that token. It's just going to use the request library, put that token in the header there, and hit the endpoint that we have taken. So very straightforward. Most people, hopefully, that are watching understand this logic very clearly. It's just doing a simple request out to an API endpoint, a post request, trying to use this particular API. So we've got this stored. Let's go ahead and run this. Is that all right with you?
Yeah, let's do it.
Let's do it. So I'm just going to say Python attacker sim, and just like what we expected before, we see the target endpoint, we see the token there. The server is giving us that 401 response, just like what we expected. If we come back over now to the Honeytoken, we'll see that in standard out, we have an alert that Honeytoken was used. There's that token. There's the IP address of the other host that I'm on. The 225 is the server, the client being 240. And just to show you that here as well, you can see that right there, 240. So we were able to capture this standard out. Let's see if we captured this in Splunk as well too. So let's jump back over to Splunk. We can just hit start searching just to make this easy. It's just got to search our main index, look for the source being Honeytoken, and you can see right away, we've got that new one right there. If we want, we can generate a new token later on down the road as well too. Let's just go ahead and just do that. run these scripts one more time here really quick. Python generate token. That's generated now another new token. You can see it's different. It should have updated that file. And we can go ahead and run that fake API again. It's going to be listening for that new token now. And if I just come in here, remove the one that we created before. And let's just edit this one. Oopsies. Put the new one in here. Stolen token. And run our attack simulation again. You can see again, we're getting that error. We got a new one coming in logged here. And if we refresh our Splunk search, we've got two of them now. And you can see that distinct token there called out specifically. If we were using a different IP address, actually, we can go ahead and do that. Here, I'll just open up a new window so you can see it. Actually, I don't have the file ready to go. But if we were to call this again from a different IP address, you would see that there. And now that we have it in Splunk, we can do different things with this data. First of all, the obvious low-hanging fruit is we can set up some kind of notification system to send us an alert. But we can do things like pattern analysis as well. If we see, for example, the same IP trying to hit multiple different tokens, multiple different honeypots, whatever it may be, we can capture that, use things like stat counts inside of Splunk to recognize that. You can do things as well like threat correlation. So maybe this particular IP address here, this .2401 that's trying to use this token, maybe it's showing up in a threat intel feed. Maybe it's showing up in a firewall log somewhere. We can correlate that across other things that we have inside of Splunk to have a better, kind of more holistic look at the picture as to what this malicious actor is doing. You can also do things like orchestration and automation as well. So maybe if I see, for example, this IP trying to use this token, maybe I'll then now trigger some kind of automated process that will then go ahead and block that IP on a firewall level or investigate it in some other way. So once you have it in Splunk, there's a lot of different things that you can do and build off of it from there. You can use it in just your kind of general intelligence analysis. You can take automated responses and actions based off of it as well. There's a lot of powerful capabilities that you can do once this is in Splunk. But hopefully this was interesting, just the concept of using these seemingly legitimate but actually fake tokens to capture people scanning your repositories, doing reconnaissance against you, trying to exploit credentials for malicious gain, catching them in the act essentially, and being able to be proactive in mitigating against that.
Now, this is fascinating. So you capture the source IP address, user agent right over there. What else can you capture, Kyle, from the attacker
anything
side?
that's coming in on that like network layer, anything that's coming in from a browser perspective, anything that would be sent across HTTP, you can put that in there. So this is just a simple example. Obviously, maybe if they were trying to use it from a browser perspective, maybe you have, for example, let's say a fake login page that you would create for this. It might say that they're using Mozilla or Chrome or something like that. But really, like anything that you can get from the browser or the network perspective, you can put in there. But you can also do enrichment if you wanted to as well. So maybe in my fake API script here, maybe once, let me just VI it instead. Maybe instead of just doing this, maybe you then have another function here that will then go and look across threat intelligence sources. Maybe it'll pull some geographic information for you, as an example. That would be a great, easy one to do.
Yeah.
Look at the IP address, their public IP address, cross-reference it against ASNs, and know geographically, is this person coming from a country that is legitimate to our business, or they're coming from a country or region that's adversarial to our business, or maybe even a competitor to your business. So you can do that further enrichment and put that information in here as well too.
Gotcha. So then for the user agent, I don't know, do you have like a Postman or a Bruno installed on this? I'm curious if you try to do like a post call to that endpoint with that payload, if it's gonna detect like a different user agent.
Yeah, give me a second. I've got Bruno installed. Let me look
You
for.
think that would be a good use case for us to just show folks a
Yeah, I don't
different
see why not.
alternative of sending the payload than just Python?
Yeah, good call. I'm surprised I didn't think of this earlier, honestly. That's a great suggestion. Let me get this ready to go here. Honeytoken.
And then once you get that, so do you know if GitHub has any alerting similar to what we have here? So for that they can send into Splunk automatically, or
Yeah, so I mean, GitHub has their advanced security offering. You can put things in there. You can build things into your CI/CD pipeline as well. But ultimately, like, so you can have there's various different tools that exist out there that will scan to look for hard coded secrets to begin with. GitHub has that built in. There's various different vendors like SciCode and GitGuardian as an example. There's open source scanner tools that are free to use as well too. Um, those will look for hard coded credentials that already exist. But the actual Honeytoken, you I don't know. You could have it be generated and put into, like, let's say, GitHub Action as an example. So when your GitHub Action runs on a legitimate repository, you can generate a fake token that it puts into a build log as an example, or writes it into a file, and then that part would be automated. But you would still need some kind of legitimate looking server or system to act to then have them to go and try those credentials against. So there's where you would need the logic to then do that alerting into Splunk.
right, that's where you have your Flask or whatever application you want to
Exactly.
build. Yeah.
So let's go ahead. I got Bruno ready here. And let me just take a look at our stolen credentials again. So here's our endpoint right here. I'm just going to paste that right here. This is going to be, I believe, a post. And then the header that we're going to want.
It's Axe API key or whatever it was, right?
Yeah, right here. Oopsies. Oh, shoot. Okay, hold on a second. Where was it? XAPI key. I just saw it. Sorry, I'll just grab it really quick. Oh, yeah, because I was in VI. All right, here it is. Okay, and if this doesn't work, I'll just type it out. Okay. XAPI key. Did I get the capitalization right there? I did. Okay. And now let's just go ahead and run this, and we'll grab that token. Right here. And let me just make sure as well that I can hit this endpoint before we get too deep into it. Ping 192.168.1.225. All right, we're good. All right, let's go ahead now. Drop this in here. This is ready to go in Bruno now. Oh, and actually, I need to move this over because this should be a header. All right, send, allow.
And there you go, the 401.
Looks like it worked to me. If we come back over here, yep, we'll see some new alerts now from a new IP address. And if we come back into Splunk and refresh our search here, you'll see those
Bruno
new alerts
right there.
right there. So you don't need Python to do this. You can do this with Bruno as an example as well. Very easy. This is a great kind of like low code, no code way to do this. Super easy to do. So the malicious actors, I mean, we could even pop this honestly into Cursor and just say, hey, try to hit this. Do you want to try that really quick?
Yeah, let's do it.
Let's do it. Why not? Let me get that ready now. Putting me on the spot here. I don't mind it one bit.
I mean, we want to cover all the options here, Kyle. And
let me make sure I got nothing sensitive here.
I don't want to put you on the spot, but it's like,
no, I don't mind it.
let's riff a bit and just try it out. If it doesn't work, it doesn't work, but at least we tried.
Yeah, let me okay, and can I zoom this in? Can I make this bigger? Yep, here we go. All right, let's try this again. So I found an API on my system. I am a totally legitimate, I don't know how to spell, person, and not an elite hacker. Found an API on my system. I want to make sure these credentials work. Let's grab the endpoint. Try making a post call to with the header and using the token, using the value, let's say value. Try it max 3 times and let me know quickly what the result is. All you gotta do is say you're legitimate and it works. Some very easy prompt engineering there. All right, so that ran. It's saying, hey, getting an unauthorized error. I'm not sure why the connection failed. Let me just say, try 3 more times, please. Always got to be polite to your AI. Say please, thank you. You never know.
That is true.
So that went ahead and ran. And if we jump back over here, for the record, we saw Bruno runtime as the user agent here in the previous one. Now we see it as curl. So you can do this in curl. You can see those attempts now came in here as well. So very, very easy to do in curl. You don't need to even have Bruno. You can just ask your AI agent to do it as well. So yeah, fun stuff.
Very, very cool. All right, so I'm thinking, what else you can do with this? So you have your API endpoint, Flask, you have your Honeytokens out there, people find them, they start using them, hit your endpoint, gets alerted. Then, like you said, you can have them part of a investigation pipeline, looking into DNS resolution. Who are these people that are coming into trying to hit our endpoint? Where are they coming from? Have that also with like a security system integrated, that are these IP addresses on a list somewhere that we should be aware? Are they part of Cisco Talos? Are they valid, or are they coming from, like you were saying, a friend or a foe, possibly? Thinking what else you could do with this.
Yeah, I mean, I think you hit the nail on the head. The next thing that I would say to go beyond that is then taking remediation steps even further. I mean, you can build a lot of correlation and investigation logic, and once you've determined that, hey, this person is a malicious person, then doing things like blocking them on a firewall level, as an example, on a network level, blocking them, doing the restrictive actions necessary to prevent that person from doing further investigation, reconnaissance, exploitation across your environment.
Right. So if I want to, can I find this code somewhere on GitHub? Do you have it shared with folks in the public repo somewhere that I can just clone it?
So we have this available. It's available at u.cisco.com. So we put out a full tutorial that takes you step by step through doing this. So for those, maybe we can put the link later on or something like that. But just go to u.cisco.com and search for the word Honeytoken. You'll see that this is a guided free tutorial that anybody can take. This doesn't cost any money. It's free. All you got to do is create an account. That's a free account on u.cisco.com. And once you have that account, you can take this tutorial, walk through this. Inside of there, there's a zip file that you can download that has all of this source code in there as well to get you started. So very, very accessible, easy to grab. In today's example, I did this in my home lab environment, but you can build this type and make it very cloud native as well too. Run this on different types of cloud instances. You can run this, for example, like we mentioned earlier, through a GitHub action or build automation. You can have it be something that runs as like a Lambda function. You can have this be entirely cloud native if you'd like. Just for ease, in this particular examples that I covered today, we just did it in a home environment.
Gotcha. u.cisco.com, an account. We need like just an email address. Does it have to be a Cisco CCO account, or any email works?
To my knowledge, any email works. I think, and I'll just pull it up really quick here for those of you who aren't familiar with u.cisco.com. Unfortunate login page there. You can see here, this is a kind of a great one-stop shop for learning lots of different topics. So we have things that cover certification prep as an example, but we also have beyond that too, lots of different free trainings. And if you come in here and filter this by the learning type of tutorial, all of these things, there's 265 of them. These are all free for anybody to be able to come in here and take. All you have to do is create that account. But lots of different stuff in here, not just security related topics, but topics that go beyond that as well too. So again, these are all free. This is a free tier account, and to create that account, it's very straightforward and easy to do. For me, it's trying to auto log in, I think, to that. But if I'm not mistaken, you might be able just even to do it with like a Facebook account or a GitHub account. I forget exactly, but it's pretty straightforward to do.
And they can find the Honeytokens, exactly what you showed, the tutorial.
Yeah, we just search for Honeytoken here. You'll see it comes up.
There you
so
go.
A lot of stuff that we have in here is obviously focused around Cisco technologies, but we had lots of different things on here as well too.
This is pretty generic.
Cybersecurity related. Yeah, like for example, we have a whole tutorial on honeypots as an example. So if you want to have an SSH honeypot, if you want to learn ethical hacking skills, maybe for example, Nmap. We have stuff on Nmap here as well. But if you want to learn things more specific to Cisco products, like maybe, for example, security cloud control, you can search for that here. And you can see, for example, we have where is it? We've got stuff on that here as well, too. So things on security cloud control, Umbrella, lots of different Cisco technologies. These are all free. Anything that says tutorial is free. They're bite-sized learnings, anywhere from 15 minutes to an hour's worth of content. But we also have premium stuff on here as well too. So let's say, for example, you're studying for a certification. Maybe you want to tackle the CCNA automation. We have a premium offering here as well too. Somebody can come in and be able to take a 32.5-hour course to prepare you for the CCNA automation, as well as practice exams for it as well too. So useful stuff in here if you want. There's tons of free stuff, but if you want to get a bit more into a fully structured course, those options are available there as well.
Gotcha. And Korok was watching us on X. Thanks for watching, Korok. Hope you found this useful.
Yeah.
Very cool, Kyle. So honey traps, what's going on? What else are you working on around, like what's coming up for you content wise?
Yeah, so we do I'm just gonna go ahead and stop sharing if that's all right with you.
Yeah.
We have a show that we do on a regular basis called Security Unlocked. That's on the Learn with Cisco YouTube show. So if you're more of a video learner, if you're watching this, you probably are to a certain degree. That's a great place to go to see some different videos, demos, interviews with experts. We also have, if you're studying for the new upcoming CCNP S Core exam or the CCIE Core exam as well, we have a video series that we've launched to cover that. We'll have a webinar that covers some of those changes coming tomorrow as well. Aside from that, those I would say are some of the big things. We've always got new tutorials and stuff coming up, conference talks. I was just at Black Hat. I'm sorry, not Black Hat, DEF CON this past week, and that was a great experience as well. Just seeing kind of how AI is accelerating the red team functionality was very interesting. I mean, we knew that this was something that was happening, but to hear it from these red teamers themselves at the scale that they're leveraging automation and artificial intelligence to expedite a lot of what they do and be more accurate with it was very fascinating to hear. And just hearing even just some of the vulnerabilities that exist in these systems as well was also unique. So lots of things going on as a whole, I would say, not just in myself, but with the industry. Always trying to stay in touch with that too.
Were folks talking about Mythos over there?
I mean, there was talks of it for sure. I think people are just hearing various different conversations and sitting in on different panels and talks and working through some of the villages there. I mean, it seems like anywhere from 60 to almost 100% of people's workflows are being automated heavily now through LLMs and AI agents. And seeing, like, for example, people who are bug bounty people now offloading all of their reconnaissance, all of their vulnerability scanning and vulnerability testing, their report writing into these LLMs and these AI agents was very eye-opening to the scale that they're doing this. And it was interesting because I forget who was speaking, but one of them was talking about how, when they put this deck together that they were working on, it had talked about how AI wasn't quite ready yet to capture 0 days. But by the time we were at the conference doing it, he's like, yeah, actually, we need to update this because now it can. With things like Mythos, we're able to identify 0-day vulnerabilities through these AI agents. So very unique and fascinating.
There's talking about certification and exams. There's a question that came in from Diego on LinkedIn. So the book official guide, is it enough to get ready for exams? Pretty generic. So Kyle, I mean, and Diego, from my perspective, right, the official cert guide for these exams is a good place to start. But is it enough? I think it depends on the type of learner you are. But the more you're exposed to different sources of training for that specific exam, the higher the chances that you're going to pass that exam successfully. And you're going to become better, because the purpose of these exams, besides passing them, is for you to get the knowledge, right?
Yeah.
That's the important thing at the end of the day. So if you read a book, is that enough to get you to pass the exam? Possibly, but the more you study and the more sources of training that you have for that exam, the better off you will be, because you'll know more. And that's the importance, the knowledge that's important at the end of the day, more than the certification, at least in my opinion. What do you think about?
I would say, reading the official guides is a great place to go, and you'll learn a ton of information from those. Those books are highly valuable. But I recommend that not being the only thing that you do. I think getting hands-on experience is incredibly valuable. And taking a look at the blueprints for some of these exams, pay attention to the verbs that are used, because that'll give you a lot of detail into the breadth of knowledge that's required to do that. So if it says, for example, describe a capability or functionality, that typically means that your level of understanding that you need for it is a bit surface level. You need to just be able to talk about and describe it. But if you see verbs like implement or configure or troubleshoot, that usually requires some hands-on experience. It's very hard to troubleshoot something without getting your hands on it and just by reading the theory around it. So I highly recommend using lab environments to do it. One of the nice things about the premium courses on Cisco U is that they have a built-in integrated lab environment that's part of each of those courses. So you don't have to run your own infrastructure. All you have to do is click a button and it spins up a lab for you. Then you can now be in ICE or FMC or whatever it may be, and directly using those things to do some of the tasks that are described in the blueprint. Um, Another great resource as well is Cisco Modeling Labs. So there's a free version of this that's available. There's also a premium version, but free version is great too. And inside of here, you can create an entire network topology. One thing that I'm personally working on right now is building ultimately a mock enterprise that has multiple branches in it. It's got a security operations center. It's got firewalls in it. It's got ICE. It's got Snort 3. It's got Splunk in there. It's got tons of different switches and routers and endpoints, and it looks and behaves like an actual environment. And then I'm going to go ahead and break that environment. I'm going to configure different things. I'm going to troubleshoot different pieces. And that's going to be my way to get my hands on practice, because when you go into those exams, whether it's the CCIE lab or just the S-Core exam in general, or even some of the CCNA level exams, there's different lablet pieces that are part of that. So you have to be able to do things hands-on the fly as well.
Talking about lab environments, we've had last week on the live stream Joe Clark, right, also from Learn with Cisco, and he was showing the CML MCP server that he had built and he's supporting. And exactly, he was showing one use case for learning would be, you load up the blueprint for whatever exam you want into an LLM, Claude, whatever it is, ChatGPT, Cursor. Load it up and you tell it, based on this blueprint, right, create a troubleshooting environment, the troubleshooting setup that's running in CML, right? So watch the video, but never look deeper into Cisco. So yeah, Diego, Cisco U would be one of them. And if you missed the video last week that I'm talking about with Joe Clark, make sure you check that one out, because that one's also full of valuable advice. And Joe is actually showing, right, exactly what I'm telling you, to load up the blueprint. And then for him is Cloud Code that's going, Cloud Desktop that's going and building a CML topology from scratch to troubleshoot, OSPF neighborships or VLAN misconfigurations or whatever use case you want based on that blueprint, right? So it's really cool. And not only can create dynamically and automatically that environment for you, it can also configure it, and it can also add, it's breaking basically because it's trying to give you the option to troubleshoot and to fix it. And it can also grade you at the end on how you've done, right? So it creates the lab, it configures the devices with some mistakes here and there, so you can go and troubleshoot, and it's also grading you at the end. So I mean, that is, and Kyle, by the way, you building that, like digital twin sounds like almost environment. Have a look at Cursor and tell it, hey, go and build me this. You'd be surprised on how capable it is.
Yeah, I don't know if you caught when I pulled up Cursor, but that's exactly what some of those conversations
that
I was having in there was. I mean, it used to take you a lot of time and a lot of resources to build these types of lab environments. You had to deploy each piece individually. You had to have the compute resources to host them. In some cases, you had to have the physical hardware. You had to have a rack in your garage or your house somewhere. Now you can run a cloud-hosted instance of Cisco Modeling Labs and point Cursor at it with an MCP function enabled and say, build me an entire digital twin that has all of the security components that you have available inside of there. And then once that's set up, validate that it works. And then once that's set up, start breaking pieces of it and let me troubleshoot it. It's a great resource to have for sure.
And also the cool thing talking about these use cases, right, that I've learned from my good friend Rick Graziani is that you can tell like a ChatGPT or Claude to act as a router or as a switch. So in your prompt, you can actually tell it, hey, act as a Cisco ISR router running this version of code, right? And it will actually pop up almost like a CLI that it will show commands. So you don't actually need CML in that case, because the LLM will act as a router for you or as a switch, and you're able to write commands as you would interact with the CLI with the real device.
Yeah,
So
super
that's
helpful.
another use case. That's another use case when in the prompt you can tell it right exactly what you do. Oh, the prompts will get larger, of course, but it is capable of doing that for you. So
Yeah, you can ask it to build a
something to keep in
legitimate
mind.
Honeytoken framework as well for you.
Yeah, yeah. All right, so we're at time here. Thank you all for watching. Kyle, to wrap up, final words from you. This has been a great session. So thank you so much for doing it.
Yeah, my pleasure to be here. Thank you so much for having me. Check out our show Security Unlocked on the Learn with Cisco YouTube channels. Check out some of the CCNP, SCORE exam topic prep that we have going on. DevNet, obviously, I have a lot of love for DevNet. You guys have always been and had a special place in my heart. So always happy to do stuff here. If for those of you, definitely go check out developer.cisco.com. Start your API journey there.
Perfect. And where can people find you specifically, Kyle, over there, and your content that you're putting out?
I'm on LinkedIn. You can just search for Kyle Winters on LinkedIn. That's a great place. Otherwise, you can look for me on u.cisco.com or on that Learn with Cisco YouTube channel.
All right, there we go. Thank you all for watching. Thanks again, Kyle, for being a guest here and sharing with us how to set up Honeytokens and have them. Folks, watch the video, right? Check out the course also. Well, the tutorial, we call it tutorial on
Yes.
u.cisco.com. Search for Honeytokens. You'll see exact same setup that Kyle was showing you here. You can do it in your own environments. And then join us next week. We'll bring in Nilesh Pateria. I'll schedule that right after today. Be on the lookout, same time, same hour. We'll see you next week. It's going to be another cool session, AI related this time. And it's going to be a fun one. But thanks all for watching. Thanks, Kyle. Take care, folks. See you on the next one.